Hello and welcome back. This is going to be part 12 of the Hare programming series, and we should be getting close to the end, and this video is going to close out this last section. I think there's about three subsections left. So let's not stand on ceremony, let's go ahead and get started. So go ahead and copy and paste this into your text editor. So pointers in Hare by default cannot be null. In other words, all pointers must refer to a valid address. However, it is often useful to signal the absence of a value, and we can do this with a nullable pointer type. Now, many of you are no doubt familiar with null, the concept of null, kind of the history of it. You know, the computer scientist Tony Hoare famously called it his billion-dollar mistake. And it is a helpful concept, but languages nowadays are tending to avoid null if they can, and Hare basically does that. So the print chords function in the sample code accepts an argument of type nullable pointer to chords. You cannot dereference this type with the dereference operator or the member access operator like we ordinarily can. We must first test if it is valid. One way to do this is to match against null as shown here. So that would be right here. We are passing in a nullable pointer to chords, and we are matching against null, and if we get a valid pointer, we're going to dereference it here. Hare also includes a feature called auto dereferencing, which allows you to do things like using the member access operator to access struct members via a pointer. This allows us to use this syntax rather than this syntax. Notice this is an explicit dereference. Many other features work similarly: indexing arrays, append et al., covered later, and so on. This works for any level of indirection. Pointers to pointers to pointers to pointers can also be dereferenced automatically. So let's go ahead and jump over into the text editor. This is a pretty straightforward example. Now, I'm using Vim. It's been a while. I just put out a video on Vim Classic. That's what this is. I'm still getting used to the key bindings and everything, so if I make a mistake, I'm still just trying to get used to the key bindings and the workflow. I have nerd tree running right here, and you can see I have airline. I don't need much more than this. I don't know if you've noticed this whole series. I don't use an LSP or anything like that. I just program. I think you learn better that way. So here we are creating our struct of chords with two int fields, and we're constructing it here, and then we're passing null into print chords here. Now, you can do this because this is a nullable pointer. That's the only construct in the language, as far as I'm aware of, that has the ability to hold null. But the thing is, you cannot just dereference it. You have to first match against it. So we're matching right here on the object, on the variable that we pass into this function, and if it's null, we are terminating our program. But if we get a valid object, a valid pointer, we're dereferencing it here. So that's what this is. Oops. So that's what this is, okay? This is a pointer dereference, and so is this. If you remember from the section that we just read, this is automatic pointer dereferencing. Now, I personally don't like this. I wish they would have just kept C-style syntax. I think that's very easy to grasp when you're looking at the code. And the reason I don't like this is because you can't look at this and understand what's happening, okay? So in a sense, it's almost like, you know, if you had like function overloading or operator overloading, there's something going on that you're not aware of. This is basically a form of hidden control flow, okay? Okay, so let's go ahead and run this program, and you can see, so what's going to happen is, so we're passing a null, and it's just going to print null. And then we're passing in a valid reference. I'm just so used to calling this a reference. It's a pointer, but it's a reference to an object. And then it's going to print the values here. So let's run this. And you can see here's null, and then here's the values. So by passing null, you cannot just automatically dereference that pointer. Okay, it stops you. The language stops you from doing that, and you first have to check. Okay, so I can, let's say, well, it's not going to print null, but I'll just call it n, and it's the same thing. And let's say, and we'll just try and print the value, okay? And let me go ahead and call this right here. I'll say print null. What am I doing here? And let's just pass a null, okay? And now let's see what happens when we run this. You see, cannot dereference a nullable pointer type. So you can't just dereference this. You first have to check for null and make sure that that's clear before you dereference that. So that is the section on pointers and nullable pointers. Other than that, they're pretty straightforward, just like pointers in any other language, C or C++. Well, they have smart, gosh, the name escapes me. Anyways, so they're just like pointers in C. Okay, there's not much difference to it. You can auto dereference, and you do have a nullable pointer type to where you actually cannot dereference a null pointer. So that is the main difference. You are guaranteed to basically always point to a valid object. Okay? So let's go ahead and move on to the next section. Okay, so to continue on this next section, which is struct subtyping, this is a bit of an involved example, but the concept it's trying to display is pretty straightforward. Don't get discouraged by this example. Okay, we'll go over it briefly, but I actually wrote a sample program to demonstrate the concept that it's trying to teach. Okay, so don't get discouraged by this. Okay, this is a little bit involved, but I have a simple example. So pointers to structs enjoy a special feature in Hare, automatic subtyping. Essentially, a pointer to one type can be automatically cast to a pointer of another type so long as the second type appears at the beginning of the first type. This is useful for implementing abstract interfaces in Hare programs. This sample program takes advantage of this by implementing a custom I/O stream that limits the total amount of data which can be written, essentially demonstrating a slimmed-down version of the standard library's built-in limit writer. Running this program only writes the first 5 bytes to standard out, hello, and that would be right here. So we're specifying the bytes and the handle or the stream, and so this would be the first 5 bytes. The pointer to limit passed to the fmtf println call, which is right here, okay? Oh, where was I? Is of type pointer to limit stream, which embeds the IO stream type as the first field. Okay, so that's right here. So it's a pointer to here, it's a pointer to this type, okay, which this is the constructor for it, okay, we're constructing the limit stream here, okay, and it's returning a limit stream, and this is what it's trying to, this is the point that it's trying to make, is we're embedding the IO stream as the first member of this struct, okay, so keep that in mind. Okay, so it's saying it embeds the IO stream type as the first field, thus we can safely pass it to a function expecting a pointer to an IO stream, such as the fmt fPrintline function. In the limit_write function, we cast this pointer back to a pointer to limit stream so that we can access additional data we need to store to implement the limit writer functionality. And that's right here. We're casting this type to a limit stream, a pointer to a limit stream. Now, the thing about it, I'm not going to explain all of this in detail. Okay, I'm going to give you, what I want to try and do is give you the tools to understand this, because when I first came to this concept, this specific example, I looked at the Hare tutorial, I don't know, at this point probably about 2.5 years ago or so, maybe 3 years ago. And I was perplexed, okay, so it just takes a little bit of time and effort to understand what's happening. So let's jump over into the text editor, and I wrote about, I would say, as simple a program as possible to understand the concept of struct subtyping in Hare, okay? So let's go through this. So we have a struct, and I just named it inode, and it just has 2 members, okay? Now here's our constructor. Okay, we're returning an inode, and we're just constructing it with the 2 values that we pass in. And what I've done is I've written a function to test this. This is going to be the test function that that tests this concept. Okay, now you can see it's called add inode fields, but basically what it does is just adds the 2 fields. But you can see, okay, notice here, see the type? Okay, it takes a pointer to inode, okay? And that is the concept here that it's trying to get across. Now, so now we have a data struct, and as the first member, you can see I've embedded an inode type, which is the struct that we defined at the top of the file. And you can see type inode appears at the beginning of type data. Therefore, data can be cast to type inode. Okay, this is the concept that example is trying to show. So let's go down. So now we have our data constructor, okay, and it's just returning a data struct. It's constructing a data struct and returning it. But you can see here's the inode. Okay, so it's constructing we're calling the function to construct an inode inside of our data constructor. Okay, now here we are constructing a data struct. Okay, so we're calling data init, and I'm just calling this a data node, and we're just passing in 2 random values. They're ints, right? Now this is the key right here. So here is this function which is add inode fields. Now you notice, okay, this is a data constructor. So this is returning an instance of data, right? Which is, if we go back up a little bit, right? That's right here. Here's our data struct. Okay, but we're passing in a pointer to it. We're passing in a pointer to the data node. But if you remember, so this is a data, right? This is a data struct. But if you remember, if I come back up here and we look at the add inode fields function, this takes a pointer to an inode, okay? So, but the reason it can do that is, again, because we're embedding the inode type right here in our data struct. So let me go ahead and run this, and you can see that this runs just fine. And you can see it adds the two values together, just like if you were to pass an inode struct into the function. So it behaves the same way, and that's the concept that this is trying to point out, okay? So let's walk through that again, just to make sure it's clear. So we have an inode struct, okay? Type inode, it's a struct with two int values, okay? Here's our constructor, and we're just returning an inode, okay? Now, here's our add inode fields, and we're adding the two fields of the inode type. And again, notice this takes a pointer to an inode, so this type here. Okay, now when we come down to our data struct, that's what it's trying to. This is the concept of struct subtyping. So type inode appears at the beginning of type data. And you can see, therefore, data can be cast to an inode pointer, okay? So when this function needs a pointer to an inode, because it's embedded right here is the first struct member, we can cast, we can treat a data struct, a pointer to one, as if it's a pointer to an inode struct. So we just have our constructor here, and we're actually creating an instance of it here called data node. You see where this is data init, so it's constructing it returns a data struct, and this is it again right here. I need to have a little bit more scroll off space, and so when we pass a pointer to a data node to our add inode field, it takes you can see it right here, it's still visible. It takes a pointer to an inode, okay? But because we embedded the type, which is right here as the first member, we can do this. So we can pass a pointer to a data node, and it treats it just like a pointer to an inode. So hopefully that's clear. I can understand that might be a little confusing. Trust me, when I first looked at this example and I was trying to grasp what was happening, I mean, this is when I was first starting to learn programming in general. But I can understand that this can be kind of a confusing thing, and that's why I wrote this sample program, because this is about as excuse me, this is about as simple, I think, of a program that you can write to kind of explain this concept of struct subtyping. Okay, so I understand that might be confusing. Please go back and watch this section again if you need to, and recreate this program. I can put this in. You know what? I will upload this specific program to my SourceHut repo, and I'll leave a link in the description if you want to go ahead and grab this specific example, and you can study it and look at it and walk through it so that you can understand this concept of struct subtyping. Okay, because like for example, like where you would actually see this would be where's somewhere that I've seen it. I think a file system iterator. Okay, so if you're trying to construct a file system iterator, you can see a directory iterator. To implement a directory iterator for a file system, right, subtype this struct. So you're going to subtype this into another struct, and then store any necessary state and populate the pointers with your implementation. So this is actually a concept that Hare uses, okay? And again, like it says, this is a convenient way for constructing interfaces, okay? For implementing abstract interfaces. So this is an actual feature that you're going to see. Now, I don't pretend to be an expert on this feature and everywhere where you can use it, but I do understand the basic concept. So, I will leave I'll put this up on my SourceHut and leave a link to this program down in the description. Okay, so hopefully you can walk through this if that's been confusing, and trust me, that's understandable. It might take a little bit to grasp what's actually happening here, okay? Okay, so now let's go ahead and move on to the next example. Okay, nested tagged unions. Now, this program actually will not compile, which is fine. I have an example, and that's because they have removed some of these, one of these modules. So let's take a closer look at tagged unions in Hare. Tagged unions have three important properties. They are commutative, associative, and reductive. This is illustrated by the commented out version of the signed type in the sample code. The order of types, inclusion of the same type more than once, or use of nested tagged unions has no effect on the final type. And that's this right here. So it's saying this is equivalent to this. And I'll show you if we jump over here. So commutative, the order of the types does not matter. And that means, so we have a tagged union of an int and a uint, and this is the exact same as a uint and an int. Now that might be apparent to someone looking at it, but when you're defining language semantics and like a spec, you have to define all of this in a very precise way. So associative, inclusion of the same type more than once, has no effect. So that means this is meaningless. This reduces to just a string. And so tagged unions are reductive, and that means this tagged union type is the same exact as this tagged union type. So see, this is a nested tagged union, but for all intents and purposes, it's the same exact as this. Okay, so commutative, the order does not matter. Associative, the inclusion of the same type more than once does not matter. And reductive, nested tagged unions. This is the same as this. Okay, an exception to this occurs when using type aliases. A tagged union, which contains a type alias referring to another tagged union, does not reduce unless you use this operator. The integer and numeric types in our sample make use of this behavior. So that's right here, integer and numeric. Make use of this behavior. This reduces the size of the final type by not nesting tagged unions, but is undesirable when the underlying representations should be distinct. Two error types, which are type aliases for avoid error, would not be distinguishable if you used this operator to incorporate them into the same tagged union. And so what that means is this right here. So normally, if you remember, let me go up a few examples. I think it's right here. So user-defined types. If you remember from this example, these are two distinct types within Hare's type system. But if you were to incorporate these into a tagged union using that operator, now I can look in the language spec. I should have looked to see what the name of that operator is. Then they would reduce. There's no difference between them. You would not be able to distinguish between them, and that's what I'm illustrating right here. So normally, right, just like this, these are two distinct types. They have two distinct type IDs. We have error 1 of avoid error, error 2 is avoid error. Now these are normally two distinct types from each other, but when you incorporate them into the same tagged union using this operator, and I just have total error, now all of a sudden the type system will not distinguish between the two of them. Okay, so that's what this example is trying to highlight. And the reason that this program won't compile is because they have removed the type submodule here, so you can see type store. So we're importing, if you try and run this on 26, you can run this on 25 too and below. So you see Hare types. If you try and run this on, I'm on Hare version 0.26.0.1. And if you were to try and run this program, it would not work because this module, as you can see, they've removed it. It doesn't exist. Now, if you wanted to and we could say, so you still, like if you're on 0.25.2, you can see it right here. I'm inside the Hare module, and you can see it right here, types. Here's the submodule. And so here's the source code for it. Like here's type x86, which would be right here. And you can look at the source code for it. But the point is, this will not compile on 26 and above because they have removed that submodule again. They've removed that submodule, so that's why I'm not running this program, because it won't compile on 26. But the point of this program is it has to do with tagged unions and their semantics within the language. Okay, and again, it just means that they're commutative, that the order does not matter. They're associative, the inclusion of more of the same type more than once does not matter. And they're reductive, which means this nested tagged union just reduces to this right here. Okay, so hopefully that's clear. If you have any questions, let me know. And I think this is the last section on this type here, the last little subsection on this. That really doesn't want to, okay, there we go. I'm just trying to get to the main menu here. Oh, I think I disconnected my internet. Yeah, that's what's going on. No big deal. I run a hardwire into my internet. It's just much faster. So that is that. If you have any questions, let me know. I will try my very best to help you out in the comment section. And I think we only have 2, maybe 3 more sections left in the tutorial before we get to the end of it. And then I would like to create a project or two. We'll make a couple of little command line tools and things like that. So thank you so much for watching. I will try my best to, I'm on a break right now from school, so I will get a couple more videos out as soon as I can, and hopefully finish up this tutorial series relatively soon, and then we can build a couple of, at least 1 or 2 simple little command line tools, and that way we can make like a real project and with like a readme and things like that, and how to organize modules, and we'll make some of our own little functions and create some little command line tools, and I can walk you through some of the standard library and kind of write the general workflow with HareDoc, and just get you to the point where you can like learn things with HareDoc, because it's an excellent resource. So that's it for this video. Thank you so much for watching. I appreciate all my subscribers. I really do. I know that the content that I make is kind of niche, and this is always the content that I'm going to make, and I don't have what you would call kind of like a real high production value like some of the mainstream YouTube channels, which, to be honest, I've kept it this way on purpose, right? Because I have no desire to like grow this channel. I just want to keep it kind of small and kind of niche and just make this type of content that I always do. So I really appreciate all of you. Thank you so much for watching, and have a nice rest of your day.